Everyone, August 20th. So today I finally um, got this one done. I think it's done. So this is a little project I had a while back that allows one to customize in React Native, right? To customize the scroll bar, right? You can customize the scroll bar because in the out of the box you cannot do much customization. You cannot change the color, you cannot change the shape, you cannot change its position. But now I write something that allows it to change, but previously I have people comment on my thing, and here, this one. Scroll content while click and touch the indicator. Yeah, I want to include, but it's hard for me. It's March. It's like almost half a year ago, right? I have this, but I really didn't put any efforts into it, which means previously when you drag this indicator, the content does not move. So finally and I think I picked it up a few days ago and start to really get into it. It's very complex. Now finally I got it to work. My goodness, it takes so long to get it to work. And this is just scroll view. Actually the difficult part is a few difficult parts. One is this one also supports horizontal, right? This is tough. And the flat list has something called inverted. Okay, and on the scroll view it doesn't have inverted, but flat list has inverted. And inverted is the really difficult one because when it inverts, it goes bottom to top. So you have to kind of change it, right, in order to do bottom top. Oh, I just realized this is not right. Oh, it's not. Shoot. Really? Please do not be like this way. Invert it. Wait, hold on. Vertical, invert. I go crazy. Yeah, it's correct by this. I think we have. There is definitely some bug. Yeah, definitely some bug. I don't know what bug it is. These look fine, and then if I do inverted, yeah, if I go scroll view, okay, horizontal, because that's what I was doing earlier. Then we go flat list, vertical, inverted. Yep, there's some issue. There is some issue. I don't know what. You see that? If I go up, it jumped out. Alright, so it's not done yet. Damn. Okay, so I have to debug this thing. What in the world? I have some suspicion of what might happen, but we'll have to deal with this. Yeah, we'll have to deal with this. This is... I kind of know what might be the issue. Yeah, I kind of know what might be the issue. Well, hey, something to do tomorrow. Anyway, let's go for today's. Dear me, I'm not ready for a difficult problem today. Old difficult problem. Strange printer. Wait, is it a very high passing rate? 50? Yeah, that's a good passing rate. That means it's not too hard. I think I probably can deal with it. Alright, there is a strange printer with the following two special properties. The printer can only print a sequence of the same character each time. At each turn, the printer can print new characters starting from and ending at any place and will cover the original existing characters. I think I remember. I probably even have done it multiple times just to practice. But lordy, I don't remember how I solved it. Oh, by the way, I reached 1500. It's just 500 more days to get to 2000 when I'm going to write another blog post. I wrote a blog post at 500 and then 1000 and the next one is 2000. So another year and a half, right? Another year and a half, and then we can write the blog post. And the next one would be 4,000 days. That's like more than 10 years. We'll see. Even I'm not even sure LeetCode can survive for another 10 years, but maybe it can. Anyway, what we're looking at, let me read it again. Print a sequence of the same character. Each term can print new characters starting from and ending at any place, and we'll cover. Okay, I know what it says. Given string, return the minimum number of turns to the printer needed to print it. To print S, right? So basically, we print A and then we print B. This one print A first and print B from the second place, which will cover the. So you can do any, right? The printer can print new characters starting from and ending at. Hold on, what's my speed right now? 2,000. Yeah, that's good speed. Can print any character starting from and at any place. And we'll cover it. So we can do any. You just cover the previous one. Alrighty, let's do this. So we're given an S, and we want to know the minimum number of times that need to be printed. So can we say likely it's going to be DP again, right? So with DP, maybe we say starting from something, or we can say ending at something. We can say ending at something. Ending at something. What's the minimum steps to print up into something? Okay, and then we want to find the next one. What's the minimum step to print that? Well, we have a string, okay? And if we want to print the next one, we can add one, just print one more. That's one option. And another option is we can say, maybe this one comes from some previous printing. Right, come from some previous printing. And if I do the previous printing, then everything will be A. Everything will be the same, right? Basically, you extend to there. And then we need to find a minimum that prints, this, the current, the ones in front. So maybe what we need to find is the minimum to print from I to J. From position I to position J, what is the minimum to print that? Right, from position I to position J, what's the minimum to print that? Then we can say from position I to I, that's, we have to print once. From position I to I plus 1, you can say, I can print that, right? Or we go before to find the, okay, from this, if we have something the same, right? Now we can say we print one round. We just print one round, and then we try to print that, right? Whatever that is, and because that's one, and then you go there. We need to print something, right? We need to print this target, and Huh. And we can say if it's the same, then we don't need to repaint. No, don't need to reprint. Right, because we go from something to something. We set it all as 1. And then up in there, we just need, because I don't have to overprint the thing that's the same. So basically it's just going to be whatever a part of it need to be overwritten. A part of it need to be overwritten. Is that right? Because you can always print over, maybe you just, you just print all of them the same. For the first letter, and we can just print everybody the same. And then we find the second letter. Because if in the middle you have, okay, I see. Let me think again. Yeah, because if you want to print a new letter, you either print it by itself, right? You can print by itself, or you can look back to find someone that's the same, and you say, we print this whole stretch, and then we will fix whatever is in between. And when you're fixing whatever is in between, you're trying to only repaint the part that is not the same. Maybe that can work. So in this case, this A, we can say we print it again, or we go before, so we do this AA, right? And then we will repaint this part. And we repaint this part, there's nothing we need to repaint, so that's actually 1, right? 1 step. And this will be same 1 step. Now here, B, I can paint by itself, or I look before to find a previous B. There's no previous B, so that's that. And this B, we look for the previous, yeah, so this will be 2 steps. Right, because we're trying to find this to this, right, this to this. We'll try to find from the start to a certain, right? This is what we want. We'll go from start to here. But in order to find from start, we say, okay, I need a first like a sliding window, right? So first is 1 by itself. It's always print 1, and then we go 2, and then we go 3, right? Then we go 4, then we go 5, because if we want to go 5, the last one requires, I have to go through 3, so the previous one I need to know what's the minimum to create that. Would that work? I mean, we can try it, but it feels, let's see, is it DP, right? Yeah, it's DP. No. Yeah, we add a new one, right? And then we can say either the previous plus one, right? That's the space. And then we go one by one, we find something, we say, okay, this one we will print, so the previous plus one plus whatever needed to fix it, right? To fix it, because I don't want to overdo it, and we have to search through this. And we say the minimum to create this, but I already create the whole thing. That's the part, and in between, because if I go from this, move to the first, that's the same, and we say boom, I'll print this whole thing, then everything in between need to be changed. That is doable, right? That is doable, because we're only focusing on just to create this, so that I can do, right? That I can do. And then I can keep going, so I find another one, then we will make this whole thing, then I'll go from this part, and then we'll skip the one, and then we do the other part. I don't know, it's is that really the best way to do this? Yeah, because a stretch, you can just keep moving until you find, you find the first, and then keep going, and then get to, and then you get another one, right? And then you can say, okay, I'll do the whole thing. Then you have this part, and then you put this part. You get a new part, because you have to handle both. I don't know. Did I do it myself? I'm not sure. What's the... Alright, what's the... Yes, print B in the middle, Well, I just want to see what the idea is behind this. I'll probably just go to my solution so I can get an idea. I think I probably wrote something about it. Oh, this is probably a bad one. Oh, what happened? Network is down? Nope, it's a LeetCode issue. Yeah, I don't think I can solve this one. Oh, wait a second. There we go. Okay, let's get this one first. So DPLR, okay, left to right, and I got a +1. What the hell? If L equal to R, return 0. Return 0. And for J, L to R, if Sj is not equal to R's right. Okay, so we'll go left to right. If it's not equal to, so if it's equal to right, I will let it go. Right, I'll let go, let go, let go. Boom, the first one is not equal. Then, for I in J to R, then we have the result is dp ji, okay, hold on. Ji is this part plus 1 plus 1 plus dpj to I and I plus 1 to R. Huh? Wait a second, what is this? If the front and back are the same, then I skip. First one, they're not the same. Then we say the result is printing the whole thing, right? Printing the 1, that's 1. And plus, because J is not the same, right? So from J to I, we get the minimum of doing this, and I plus 1 to. Why? I seem to remember this type of trick. You just and I plus 1 to R. This and this. What type of is this? And you break it after it's not the same. What you're saying is, given any range, if the front and end is the same, then we always just print it once. And then I will always say we'll do this part, and oh man, I need to see some explanation. That is correct. Yes, they can all be printed in one turn. That is a good insight. For each letter in S, there might be some print starting from that letter. There must be some that's starting from that letter, right? And if that is the case, if it's starting from that letter, there might be some print starting from that letter. If that is the case, that starting letter will not change once printed. Yes, because you will want to print something, right? You will have to print something, and that print something, the ones that we print right now will not change. Otherwise, why do we print it? We print it there go forward, and then that one is the one that gets printed. Okay, that makes sense, right? That makes sense. And basically we just go through them. We say if this is the starting point, this is the starting point, this is the starting point. I think that's kind of the idea, right? Okay, so if L larger than R returns 0, rest equal to 1 plus dpl plus 1. So the first scenario is we print this one, and we'll keep the first, and then the remaining will just change. Okay, that's the first scenario. Now the second scenario is we keep the first one, and then we do a k from L plus 1 all the way walk to the end, right? And we just say if the left is equal to, right, it's equal to, and we just say, okay, if it is the same, then we don't have to print over, and I do L2, wait, hold a second, what? If SSL equal to SSK, so we go ba 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 ba, we hit the same, okay, then we say we do this print, then we need to handle the stuff in the middle, which is dp L to k minus 1. Second scenario, what's the second scenario? L to k minus 1 plus k plus 1 to R. What? All right, let's see the second scenario. We print SL, and then handle remaining. Good. Second, we go through L plus 1 to R. Okay, L plus 1 to R, and find SK is equal to SL. When that happens, the amount of prints to make from L to K is equivalent to dpl to k minus 1. Because when we do dpl to k minus 1, we print SL all the way to k minus 1. We might as well extend that by one more position. And all the other changes needed can be identically applied to king. Okay, I don't understand what I was trying to say. So if SK is equal to SL, the amount of prints needed to make SL to k plus 1, to k plus 1, to k plus 1, to k plus 1, correct, is equivalent to L k minus 1. Well, I mean, this k plus 1 just to L to k. From L to k, because SK is equal to SL, so the amount so the dp LR means if we print SL first, okay, if we print SL first, what is the minimum number of prints needed to make L to R correct, right? So if SL is equal to SK, then we can do dpl to k minus 1. That can make it correct, right? So that's 1k. And we say the next will be k plus 1 to R. Basically, we're saying, given L to R, right, we can go through the k in the middle. So because given L to R, there has to be, right, you have to print something, right? You have to print something. And in fact, this first scenario and the second scenario, I don't know. The second scenario only check if they're equal. What if nothing? What if none of them is equal? If none of them is equal, then yes, you do the first print and you have to print the remainder, because there's no way, because it doesn't matter, right? If you don't have any repeats down the line. The difficult part is when you have repeated down the line, then you may print that stretch, right? So you print that stretch, you handle this part, and you handle the remaining part. That actually does make sense, right? That does make sense, because this K thing, right? We just say we will print the first L to K, and then we print the remaining. We print the first L to K, then we print the remaining. Now this makes sense to me. This makes sense to me. It's hard, but it does make sense. Okay, let's try just implement it, and I am going to write something again. It is Tuesday today. Time flies, man. All right, so we first say, yeah, not able to do it. $664. Is this on my, yeah, this is on the nightmare list. Yeah, very tough. I thought about it for 15 minutes, and I was pretty sure I couldn't solve it today. After checking my previous attempts, I think I understood how it was done. Now, dp LR is the minimum prints to produce S from L to R plus 1, right? To produce this with the first print being SL, right? Now there are, yes, two scenarios. First, now the base case, first scenario is that in SL to R plus 1, only SL appears only once, right? SL appears only once. In this case, we have to print SL, right? Thus, dp LR shall equal to 1 plus dp L plus 1R. Done. Is that, actually this is not true, is that we print, is that we print this, right, and then handle the remaining. In this case, yeah. Second scenario is that there are multiple letters in SL to R plus 1 that are equal, that are the same as SL. For each SK equal to SL, right? The stretch S from L to K can be produced, right? Can be produced, right? By can be produced by dp L to K minus 1. Then we only need to add the remaining dp K plus 1 all the way to the end. Now this works because we're checking every single one. Now this works because it is only sensible to print SL all the way to some letter to some SK. Now we don't know what that SK is, thus we go through all possible SK, right? All possible SK to find the optimal. Final optimization is that we don't have to use S directly, right? Instead we will pre-process S to remove any consecutive duplicates. This is because all consecutive duplicates can be printed in one go. Alright, so what I'm gonna do is I'm gonna say a list of character, okay? SS, right? New array okay, and basically we have to go the previous. Okay, so we say for int I equal to 1, I smaller than s dot size length I plus plus if s dot char at I is not equal to s dot char at I minus 1, right? If these two are not equal, then ss dot add s dot char at I minus 1, right? If the same, we just skip until the first one that's not the same, we add the previous one, right? We add the previous one, and then we go on, we add a previous one until we are at the end, right? We are at the end because we go, not the same, not the same. I'll add the previous, and it's the same, not the same. I'll add the previous, same. So, and if it's not the same as the previous, so we always have to add the last one, right? We always have to add the last one. Now so ss.add, s.char@, s.length -1. Okay, so this is ss. Okay, ss is the pre-processed string with no consecutive duplicates. Then we need to do the DP. Okay, so what we can do is, let's go here, int, okay, memo, probably not, let's do it a private int dp, int l, int r. Okay, oh, we probably need dp as well, int memo. All right, and we say if memo lr, right, if memo lr is equal to 0, which means I have not done it yet, then we'll do blah blah blah, and then at the end we'll return memo lr. If L is larger than R, so if L is smaller or equal to R and this, right? So if L is larger than R, then basically I don't do it, and then we'll return the original value, right? So if L is smaller than R, then we can do the L to R, right? And we say scenario 1, memo LR equal to 1 plus dp L plus 1 R. Done. Scenario 2, for int I equal to L, right? I smaller than equal to R, I plus plus, right? So we'll actually, I think we'll use K because in the earlier we say everything is K. Okay. So if, oh we forgot the SS, so list character SS. So we say if ss.get k equal to ss.get l, right? If these two are the same, then we can do around, right? We can do around. So we say memo l r equal to math.minimum memo l r, and it's going to be dp something plus dp something, right? So what is the first dp something? So it's going to be L to k minus 1, because k is the same, but I don't have to do it, so it's a k minus 1, it's previous. And this is going to be, you know, k plus 1, right? K plus 1 all the way to R. And of course I need to put other things, for example ss and memo, and this is the same, ss and memo, right? Oh yeah, ss and the memo. So okay, so that's that. And for here, int memo equal to new int ss.length .size ss.size turn dp 0 ss.size minus 1. What's the next one? No signature. available. That is bonkers. There is a signature. Huh. This dot. Oh, this is interesting. It cannot go to definition. No signature help. Type definition. No definition, yo. This is ridiculous. SSN memo. Okay, and yeah, this is ON tripled. All right, basically I just re-implement the previous, and then we'll see if it works. Oh, we have out of bounds. That is interesting that it will be out of bounds. Yeah, that's basically just A and B, right? So SS should be just A and B. Okay, let's take a look. Can say system.out.println ss.toString. Make sure SS is correct. A and B, yeah. So it's 2 by 2. So we'll go 0, 2 by 1 is 1, 0 and 1, right? So we go 0, 1. And it goes, I see. It's okay. So basically I will do is here, if L is larger than R, I'll just return 0. I think this will make it work. Sort of. Okay, output is interesting. It's not correct. I'm wondering why. L is 0, R is 1. And then it'll be 1, 1. 1, 1. So it'll be 1. And then K is from L to R. Oh, I see. I think this has to be, yeah, I think it has to be for int row memo array stuff fill. I don't know, fill what? Integer the max value. And then we say if it's equal to integer dot max value. Would that one work? Huh. Yep, that's correct. So L and K will be the same. I think we should start from +1 because if they're the same, there's no point, right? Yeah, let's try this. There we go. Have to be +1. Because otherwise it's the same. Like what's the point of going through this if they're the same? We can even say if L is equal to R, but that's fine. Okay, let's run the other scenario. Yeah, this is a kind of a way, like you just go through, you say, it definitely will work, right? And then we have some big fail. It definitely will work for, you know, at some time it will work, but you just need to find out at which point you need to cut, right? At which point you need to cut. I'll keep this solution. I definitely do not want to read the official, because the official is, I don't know what the official is, but this one at least I understand. This one at least I understand. But the two keys, actually two keys is similar, but this one, yeah, kind of just lost interest. That's basically what it is. I lost interest in this one. I was thinking in the right direction, that you start from something, you go to something, and I was thinking, right, you have start to end and you want to find that, then you will go through when you find the ones in the middle, right, like these islands. That's very similar, but not exactly right. It's actually, I think if I push a little bit harder, I probably can solve it, right? Because I was thinking in the same direction. You have this, you have something that's matching. I say, okay, I'll go through this. But the problem is, I add something, right? and I go backwards, and I say, okay, give me this much, and I'll do the middle, right? And yeah, I was thinking about adding 1. I add this plus this, right? And then I say I can search, this is the same, then I do this. What I didn't realize is I can do this and I add a front. It's actually, it is the same idea, but I just wasn't able to push it through. Anyway, that'll be it. That's not good, but well, we'll take it. All right, see you guys tomorrow.